Hi, my name is Sven Meyer. In the scope of the virtual CHI week, I will now take the next 3 minutes to present my paper, which was accepted to CHI 2020. The title of the paper is Improving Humans' Ability to Interpret Deictic Gestures in Virtual Reality. And this paper is put together in collaboration with Jens, Robin, Brighton, Valentin, Katrin, and Niels. In human-computer interaction, we see full-body gestures such as mid-air pointing, mainly to interact with devices. Here, a user points with his or her finger, arm, or in detail with a full-body pose towards a desired object to interact with. For instance, in this media room, proposed by Bolt already in 1980, a user was able to select an object on the screen by pointing at objects and using voice commands to trigger actions. In this specific context, mid-air pointing is understood to be purely a human-device interaction. However, in human-human conversation, these same gestures are called deictic gestures. Deictic gestures are often performed in combination with verbal explanation, such as, "Look, over there." However, it is well known that extracting precise directions from deictic gestures is hard. Therefore, a large body of work is dedicated to enhance the ability of humans to understand deictic gestures. This is especially interesting in virtual reality, as we can manipulate the world around conversation partners or even the conversation partners themselves. One simple idea, presented by Wong and Goodwin, is to augment the pointing direction of a pointing person. For instance, with a laser beam, as you can see in this illustration, or by extending the user's arm longer than normal in the direction of the desired object. Warping Deictics, a paper presented last year at CHI, is warping the arm of the pointer, enabling the conversation partner to better estimate the desired direction. However, as you can see here, they only take the up and down movements into consideration. With this year's paper, we extend upon last year's work by including also the left and right direction to further improve the observer's performance. In the paper, we first ran a study to collect data on how people point in virtual reality. Based on our findings, we built a model, which we then evaluated in a second study, comparing the non-corrected arm version with the two-dimensional warped arm version. And in fact, by bending the arm, as you can see here in the background, we were able to show that we can significantly reduce the error of the observer when estimating the pointer's direction.